Have you ever wondered where the water we drink, the water we bathe in, the water that covers about 71% of our planet's surface originates from? Many of us have grown up with the notion that Earth's water was delivered through the impacts of icy comets. It's a compelling idea, isn't it? But recent research findings are challenging this long-held belief. Instead, these new findings suggest something quite astounding. Our planet's water, it seems, might have been here all along. Yes, you heard it right. The planetesimals, those celestial building blocks that formed Earth and other rocky planets in our solar system, they already contained water. Imagine that. These ancient bodies, forming and clumping together, already had within them the very essence of life as we know it. These new insights are not mere conjecture, but are supported by careful scientific analysis and experimentation. So, it appears that the water we so heavily rely on might have been here since the very birth of our planet. Now, you might be wondering, how did researchers come to this conclusion? Let's delve into the intriguing world of meteorite studies. The scientists, akin to cosmic detectives, examined ancient meteorite samples. These aren't just any rocks, mind you. These are remnants of the primordial material that formed the inner solar system. What they found were signs of chemical reactions that can only occur in the presence of water. But there's a twist. These meteorites, as they exist today, do not contain any water. So how did the researchers find evidence of water? The answer lies in the iron. By meticulously measuring the iron levels in these meteorites, researchers noticed something unusual. A significant amount of iron was missing. Why is this important? Well, iron, when it reacts with water, forms iron oxides, leaving less elemental iron behind. This missing iron is a telltale sign of the presence of oxygen and, by extension, water. You see, water is composed of 2 hydrogen atoms and 1 oxygen atom. When water interacts with iron, the oxygen part of the water molecule can bond with the iron, forming iron oxides and leaving behind less elemental iron. This is how, even in the absence of water in the meteorite samples today, scientists can trace the water that was once present. It's like reading a story written in the language of elements and chemical reactions. A fascinating piece of detective work, isn't it? And what does this all mean for us and our understanding of the universe? Well, these groundbreaking findings have far-reaching implications, opening up exciting new vistas in our cosmic comprehension. They suggest that the primordial material that went into the making of the inner solar system probably had water in it. This is a significant revelation, as water is one of the key ingredients for life as we know it. But the implications don't stop there. The presence of water also points towards the likelihood of other life-sustaining elements, such as carbon and nitrogen. These elements, in concert with water, form the backbone of life on Earth. This suggests that the building blocks of life might not be as rare in the universe as we once thought. So what does this mean for the big picture? Our understanding of how life-sustaining elements are distributed across the universe is experiencing a paradigm shift. The universe, it appears, might be more predisposed to life than we ever imagined. But perhaps the most profound implication of these findings is the hope they kindle. The hope that life, in some form or another, might exist beyond the confines of our blue planet. After all, if water has been a part of Earth since its very beginning, who's to say it's not elsewhere too? This discovery not only reshapes our understanding of our home planet's history, but also gives us hope about the potential for life elsewhere in the universe. After all, if water has been here since Earth's infancy, who's to say it's not elsewhere too?